So today I'm going to talk about front and back end databases and like how different things connect with GraphQL and how Hasura plays a role in all of this, right? So myself, Praveen, I work as a developer advocate at Hasura. Full stack, obviously powered by Stack Overflow. And my journey has been around so I started off as like a front-end developer who used jQuery, then moved to React when the whole world moved to React. And on the back-end side of things, I use the MVC architecture like Django, and then moved to a JavaScript ecosystem, Node.js, and it was a complete shift of the tech stack that I've been using earlier, and then the ones that I've moved to. And obviously there's Docker for packaging and stuff that I typically use, right? So those technologies are important because in all of those transitions, the API layer was still REST API. Previously, when I was using Django, I used to write some models and views and controllers. When I moved to Node.js Express, I used to write some handlers, the same, right? So it was the API layer was still a REST API. Everything else surrounding that changed. But then came in GraphQL, which is going to be slightly different with the way you approach writing APIs. But the fundamental factors which influenced using GraphQL was to build apps faster. And the bottleneck of getting API access, there was a key bottleneck where REST APIs had an open-ended way of writing things, and there's no structure around. I mean, you obviously can put a structure around it, but GraphQL ensured that there is a little more structure around getting access to an API. Moving towards like a self-serve API. By self-serve, what I mean is GraphQL gives you like a schema and a type system, which lets you do documentation automatically. So GraphQL gives you documentation automatically for the APIs, and you can self-introspect the API, and which makes it a lot easier for adopting GraphQL, right? And obviously with GraphQL and the schema and the type system, you can get different shapes of data, and that is another key point in adopting GraphQL. And data sources can be multiple. REST API also, this will be completely applicable, but with GraphQL, what happens is that you have like a type definition that's there, and they can be mapped to different data sources, which means that teams can now independently work on different sources of data, and then with GraphQL they can stitch together multiple of these data sources and make the API layer unified, right? So the whole point of GraphQL is to make a unified API layer, and multiple data sources is obviously going to be playing a big role. In a complex app, you will have APIs coming in from different places, right? This could be a REST API as well. This could be a GraphQL. This could be a SOAP API, whatever, right? The data source could be anything. But what GraphQL lets you do is to wrap it over all of these and give you like a unified interface to the client, making it easy for them to query, right? And obviously the user experience around using GraphQL for front-end developers, especially because I think Tim showed a demo in the last. There's a graphical interface where you keep typing in and then everything auto-completes for you. So the user experience is obviously largely improved compared to what REST APIs had. You obviously had Swagger docs and so on for documentation, but like to quickly try out an API, get a response on a UI with auto completion and documentation and types and stuff. I think the user experience has gone a little level higher than existing solutions like REST APIs and SOAP API, right? So that's the GraphQL adoption journey, and the reasons why I personally also adopted GraphQL apart from just working in a GraphQL company, right? So so why GraphQL? some of the reasons we've seen in the previous slide. But technically, today you have like a lot of consumers, which includes like mobile apps, web apps, your microservices, your APIs. So there are different platforms, multiple platforms and multiple servers, multiple APIs, which are consuming data. And compute is getting easier. Like infrastructure is not a bottleneck anymore. You get serverless and you pay as you go, and then business logic is executed on the fly, right? So there are consumers who are varied, and there is compute which is getting easier, and you have the data access, which is the actual problem where you take a lot of time to build and iterate for data access, right? So mobile apps will require a little bit of different data set, whereas a web app will require additional data on top of the mobile app, right? So the data that's being fetched and shown is different, and whatever is consumed is different across different platforms, and obviously with other platforms also, like the IoT devices and so on. The data access will be slightly different. The amount of data that's fetched is also going to be slightly different, right? So in all of these cases, data fetching is key. The amount of data fetching is very important as well. Obviously, you shouldn't really be fetching a lot of data than what's required. So in fact, the original reason why Facebook introduced GraphQL back in the day was to optimize for mobile applications, where Facebook's mobile application in developing countries, where mobile data access was pretty limited. So the amount of data that needs to be transferred had to be very minimal, had to be the perfect data that had to be transferred. And I think that was the evolution of GraphQL itself, where data access has to be perfect and has to be limited to what is actually required, right? So that's the challenge. And if you look at who are the producers of data, there's obviously databases which store data, and there's also internal services in other teams which build APIs for custom business logic, and external services which have like third-party services like Salesforce, your Stripe API, your payments API, your Algolia search, and so on, right? So there are a lot of external services, vendors who give you APIs out of the box. Your internal services are also like your team is building internal APIs for different purposes. And there's a database which supports a bunch of these on top of all of these, right? So databases are getting better, and consumers are also getting better. The bridge between them is a data access that GraphQL is giving you, that makes this glue stick, right? So and with increasing adoption of SaaS services, it's important to actually have this data access layer solved before scaling can happen, because your producers of data will still keep increasing, your consumers will also keep increasing, but your data access layer has to be pretty much stable, right? So GraphQL enables that layer to be pretty stable. Is the whole reason why GraphQL is actually being adopted by a lot of companies, right? So now the next question would be around should I use GraphQL or should I use REST? What is the comparison, and so on, right? So it's typically not a comparison between GraphQL and REST. The first thing that people do is to actually compare GraphQL and REST because of the way they are the API layers, right? So it's GraphQL and REST, right? So the reason being that REST APIs are here to stay. There are a lot of existing tooling that still survives on REST APIs. A lot of caching, a lot of monitoring, health checks, and everything around REST APIs that have been set up in a lot of companies and a lot of API services. They will continue to work. I don't think anybody's going to migrate away from REST API to GraphQL. But what GraphQL offers in addition to that is to be a layer on top of REST APIs, and then wrap that into like a unified API layer which everybody can use, right? So it's never a comparison between whether I use GraphQL or REST. It's always going to be, and you will use both of these at some point. If you're using a complex application, you will encounter REST API at some point. So so it's not about shying away from using REST APIs. The tooling is still pretty solid with REST API, and a lot of existing setups run on it. And that's the learning that we've had, where legacy systems will still continue to use toolings around REST APIs. What GraphQL can offer in addition to what REST APIs can offer. Right? So it's always between, it's not between GraphQL and REST, it's and GraphQL and REST because of the existing tooling that I talked about, right? So what's challenges for adopting GraphQL? On the developer side, performance and caching would be the primary aspects, because with REST APIs, then you had caching, which is URL based, endpoint based, and so on. You can throw in a get endpoint and then you can put it on a cache. With GraphQL, it's a single endpoint, typically served over post, typically your request body is where your query layer is, and caching becomes a completely different game than what we do in REST APIs. Right? So that is a new challenge that people are facing. On the performance side, obviously with the whole resolver approach in GraphQL, you have this N+1 problem where you have multiple rounds of functions being executed depending on the depth of the query. Right? So, and also like if you're interacting with the database for a particular query, how optimized your SQL query or your NoSQL query is being generated for a particular query. So that's another performance issue that's typically a challenge that people face when they start scaling, right? And the authorization layer as well. But there's a silver lining to this. The authorization layer is obviously slightly easier to implement, also in the sense that because of the schema and type system, you actually know that you can restrict access to a particular type with code. So there's both sides to this authorization layer. But obviously, since things are new, authorization is also going to be a challenge, where with REST APIs, things are already figured out and done, right? So on the operation side of things, because it's a single endpoint, you will have like a single point of failure. Your /GraphQL endpoint dies, your entire server is unreachable, right? So that's a big issue with GraphQL. There's also like a rate limiting issue where because it's a single endpoint, you cannot limit this particular endpoint from being queried more than these many times because you're putting a general block on the whole URL, right? With REST APIs, you can be granular about a particular, let's say maybe authors endpoint can be rate limited, but products endpoint is probably not rate limited, right? So you have granular approach over rate limiting over REST APIs. With GraphQL, because of being a single endpoint, you have these constraints to worry about and look at the request body and then do rate limiting on top of that, rather than just the URL-based rate limiting, which a lot of tools give you, right? So you can set up like an Nginx, which does a lot of these stuff automatically for you. But with GraphQL, you will need to be more involved in the code that you write on your server side to do all of these things, right? And on the business side of things, what's the cost involved in actually adopting GraphQL? So like you write your server from scratch. Do you migrate your existing REST APIs to GraphQL, or you just write a wrapper over REST APIs? Or if you're starting from scratch, then it's a completely new thing that you write from scratch, GraphQL. So the cost involved is also like another challenge that businesses face. And what you've typically seen is people write wrappers over REST APIs rather than do a full migration, because the benefits of writing a wrapper is still largely good. And rather than writing a rather than doing a full rewrite, which is going to be very expensive in both operationalizing it and then actually maintaining it, right? So that's another challenge. So coming back to what Hasura does in all of this, so Hasura 2.0, we've launched 2.0 like a month back, with the fundamental difference of connecting to multiple data sources. So what has changed? We fundamentally now support data sources. Before Hasura 2.0, we used to support just Postgres. So what Hasura does is it connects to Postgres and give GraphQL API out of the box. And on top of that, you also get authorization, and you can add your external GraphQL server, join data between them, and so on. But with 2.0, we support multiple databases and data sources. So for example, you can connect to Postgres, you can connect to MySQL, you can connect to BigQuery, SQL Server, and so on, and more databases to come in the future, right? So the idea is that if your organization is using 4 or 5 different data sources, or like multiple Postgres databases itself, right? So in that case, you just connect those data sources and then get GraphQL APIs out of the box through Hasura, right? So that's the fundamental shift in our 2.0 architecture. And what we've also done is added an ability to create REST APIs on top of GraphQL. So what we do right now is scan to databases, give you GraphQL. With the generated GraphQL, what you can also now assign is to do a mapping of, say, create a REST API for this particular GraphQL query. So let's say I have a GraphQL query which is query author name ID, and I want this to be a get endpoint in REST API. So I can do the mapping of this GraphQL query to be a REST API, right? So what this does is for clients who are looking for REST APIs in certain cases, this will be pretty useful for like a quick REST API call that they can make. And underlying query is still GraphQL. Underlying auto generation of API is still GraphQL, but REST API is created on top of it through configuration of your GraphQL query. So that's something that we've introduced from 2.0. This is pretty useful for large companies where they don't want to move from REST APIs for certain use cases. So in those cases, they can still connect to Postgres. They can still connect. They still get the GraphQL API, but they tend to use REST API for their particular use case, right? So that's a change, and generalized authorization, right? So what you've done is till obviously 1.0, we had authorization layer for Postgres. But with 2.0, what has changed is you can, let's say you're writing your own GraphQL server in, let's say, for example, Node or Java, whatever, you have a GraphQL endpoint that you can add. So you can add that as a GraphQL server as a remote schema in Hasura. And what Hasura can do for you is to let you add permissions for your custom GraphQL server. So let's say your custom server has types like product, ID, name, or price, and whatnot. And you want the price column to be probably, let's say, accessible only for signed-in users. In that case, you can create role-based permissions inside Hasura, and then declare that, okay, this price column is only accessible by a user called role, user with a role called user, right? So that's the level of authorization rules that you can now start specifying. So this will eliminate a lot of code that you will probably write, because you still have control over writing custom code in your language or framework. But then writing authorization for that will also be a lot of more code to be maintained, right? So what Hasura does is it gives you that authorization, which it already gave you for Postgres and other databases, and extends it to your custom code as well. So you define your own types, you define your own resolvers in whatever language or framework, but then authorization is taken care by Hasura, because the client actually hits Hasura first, and then the authorization rules are being applied, and then the execution logic gets transferred to either the database or to your custom GraphQL server. And generalized joins is coming soon. We already had joins between your custom GraphQL server and the database. So if you have written your custom server and you have some table in Postgres, and you want those two data to be combined in the same API, you could already do that. With generalized joins, what you can technically do is write two different GraphQL servers and then join data between them by defining the mapping between which types join, right? So it's more like stitching and then joining data between two different GraphQL servers. And also with generalized joins, you can do joins between databases and your custom GraphQL servers. So data access between different sources is going to be pretty easy now with generalized joins. A typical example that we use is, let's say you have like a Postgres payments table and you have like a Stripe API. Let's say Stripe API has a GraphQL interface, or probably you've written a custom GraphQL interface over Stripe. You can now establish a relationship between the payments table in Postgres to your Stripe data, which contacts the Stripe service. And in the same API call, in the same GraphQL query, you will be able to now fetch the payments data from Postgres and also the Stripe data from Stripe, right? So the joining of data will be magical. It will happen in the background, and it's all declarative. When you configure it initially, it's a one-time configuration that you do declaratively, right? So that's the fundamental change with 2.0. So where does Hasura fit in the stack? So if you look at the old monolith that people use, developers like contact a monolith service, and then the monolith contacts different services. And then what has changed right now is now you have a GraphQL interface, which developers or clients contact. And you send a GraphQL query or a mutation or a subscription to Hasura with the right authorization headers. Hasura takes care of applying the authorization rules. It parses your query, and then it will send the query to the right database, or it will send the query to the right serverless function that you've configured. So it's more like a CQRS style, where you have an asynchronous flow for certain use cases. Some queries will go to serverless functions. Some queries will go to databases and give you an instant response. So it depends on what the query actually looks like, and what your query structure looks like, and your entire schema looks like, right? So basically the fundamental idea is that your clients will now contact Hasura. Your front-end client could be a React app, or it could be a mobile app, which just directly contacts the Hasura GraphQL endpoint with the authorization. Then in the behind the scenes execution where data is being fetched from different sources and then assembled it for you on the response, right? So that's where Hasura fits in the stack. The databases that we support right now is Postgres. So you always need a Postgres database for storing the metadata that Hasura stores. We also support BigQuery, Google BigQuery.
I can't hear anything.
Yeah, I've lost audio too.
Yeah. Oh, no. Oh, Praveen, you're back. Great. Oh, and you might want to unmute yourself. Perfect. Okay. Please feel free to continue.
Right. Yeah. That means. Yeah. This is visible again. Yeah, I was talking about the support for databases that we have. So we have Postgres as the primary support, where the metadata of Hasura is being stored in Postgres, but everything else can be like added as another data source to your Hasura instance, like SQL Server, MySQL, BigQuery, and Oracle and MongoDB is coming soon as well in the next 2 quarters. On the front-end side of things, for GraphQL, the challenge would be around client tooling in general, right? So there's Apollo client, which is typically the go-to choice for people, and they've done a good job in doing in making sure that your data access is pretty easy in terms of using in React or let's say Vue and so on, where you write queries and mutation subscriptions. The consuming consuming the API is pretty easy now from the front end. And the only caveat with GraphQL is that people don't realize that it's just a simple JSON body that they send as a post request to a server. Probably some of these clients have made it a magical query language, which it isn't. It's actually just a simple post request that you send, right? So you probably don't need a GraphQL client always, but the GraphQL clients also give you benefits like caching on the front end and normalized caching and so on. So when that happens, when that's a requirement, it's prudent to use a GraphQL client like Apollo client, Oracle, and so on. There's also like fluent GraphQL clients, which lets you write queries as objects, like an ORM kind of structure where you say get user.id .name .var, something like that. So basically write objects and send queries, right? So more intuitive, but there's a learning curve involved in using fluent GraphQL clients. GQLS is one that you can check it out. There are a lot of fluent GraphQL clients which you can check out, right? So and the challenges, again, on the challenges side, I think caching is still a challenge. On the front end side, tooling like Apollo gives you that, but normalized caching and how you manage state with GraphQL on the front end, that's still like an unsolved problem. People typically use their own state management libraries for all other purposes, and GraphQL clients become this data fetching layer and not the actual state layer, right? Even though Apollo actually recommends you to use their client as their state management solution. So there are like depending on the complexity of the app, I think the state management solution in GraphQL on your front end becomes difficult, right? So that's a challenge that front end clients have. But I think if you compare front end and back end developers with GraphQL, I would say front end developers will be even more happy generally because they've been given the power to now start using graphical autocomplete, get the query that they want, don't ask the backend developer, don't communicate with them, and then start using things, right? So that's the power given to front end developers, and they're enjoying the freedom that they have right now. So I don't think they'll complain. And let's move on to the backend demo. So I'll quickly show you like a UI-based demo. So this is the Hasura Cloud console, cloud.hasura.io. You can log into this, the free account. What I'm going to do is I'm going to create a new project on Hasura Cloud. Let's call this Sydney Meet. Yeah, this is available. I'm creating a region. I'm selecting the region in US West. I'm going to click on create project. So I'm creating a new Hasura Cloud project. And as you can see, there's a GraphQL endpoint that is already generated. This is sydneymeet.hasura.app/v1/GraphQL. So this is the unified GraphQL API that your clients can now start using. Your front-end app, any client can start querying, right? So now I'm going to click on Launch Console, and this is going to open up the Hasura console. So Hasura comes up with a UI to manage your the database schema, your connections to different data sources, and gives you like a graphical interface that you can try out queries over and so on. Right? So this is the graphical interface that you saw in the previous demo that Tim had, slightly modified UI to have request headers and the GraphQL endpoint and so on. So that's the change here. But let's go to data. So here you have the ability to now connect a database existing database. This could be a Postgres or a MySQL server that you can create. What I'm going to do is I'm going to create a new Postgres database through Heroku. Heroku has a free tier where you can create a Postgres database. So I'm going to click on create database. I'm already authenticated, so it's all pretty instant. So what happens internally is Hasura creates a database inside Postgres and then gives you the connection string of Postgres for you to quickly connect it here and then start using that database. Yeah, so now we've added a database successfully. Let me zoom in a little bit so that it's a little more visible. Right, so I have a database now connected. So let me go to create table. Let me create a table called users. This is all typical Postgres stuff. We create tables. This is just a UI which facilitates you to create this easily. Frequently used columns created at. I can also add foreign keys, but yeah, I'm going to click on add table. So table has been created successfully. You can see the columns that we created, ID, name, and create that, right? So let's go to API and GraphQL interface. Let me start typing out query. Should get users. Let me remove the headers, right? I have users, ID, name. So I have the GraphQL query generated automatically for the table that I've created. The query works now. Obviously, data is empty. So let's insert some data. So let's have insert users one is an object. And I can insert ID. If ID is an auto-incremental value, so I'll skip that. I'll just say Tim. And created at is also an auto-generated value. So I'm going to skip that. And I just want the name of the, or maybe the ID of the user who was created along with the created timestamp. So this is a mutation that we're going to insert. We're going to, so we are calling insert users one, which is like a mutation that was auto-generated by Hasura to insert into the users table. Once I do this mutation, I would get back the response ID1 along with the timestamp that we asked for. Right. So the mutation has been done. Let's try out the query now from the history. Let's go to query. Now we've got the ID1 and the name Tim coming in from the database. So this is pretty instant. So what you've done is just created a table in Postgres through a UI. You could create this table through PSQL interface, your normal, however you interact with Postgres, you can do it through CLI command line or just direct raw SQL statements through your database and so on, right? So this is just a UI to facilitate easier access to your database. Just think of it as like your PHP admin, a little more modern version of that. So that's what this UI is, along with few more things added to like relationships, permissions, and stuff, right? So I think earlier we had Craig asking about relationships in Hasura. So let me also quickly create another table and show that as well. So let's say there's a address table. We have address, and let's say there is the actual content of the address. And the address belongs to a user ID, which is of type integer. And the primary key would be ID, let's say. And we'll add a foreign key. So we'll say users, which should be user ID to ID of the user table. So I've added a foreign key now. User ID column will belong to users.id column. Right. So I'm going to add this table. So we have added another table called address. We have users already. Now let's go to data. And if you look at over here, you have something called untracked foreign key relationships, which means there are foreign key constraints that have been set up, but relationships have not been set up yet. So you have an ability to track them individually and then start querying, right? So I'm going to click on track for this, and I want to click on track for address as well, right? So if you go to address table, if you go to relationships tab, you have something called object relationships and array relationships, right? So what object relationship means is a one-to-one relationship. So address belongs to one user. And if you go to users might have multiple addresses. So that becomes like an array relationship, right? So what I'm going to do now is create an address, sample address, and I'm going to send this to user ID 1, which we created in the previous step. And now what we're going to do is, so we have the address table, ID, content, user ID. And we also have the user data coming in the relationship. So it will be ID name. So we've been able to now fetch the data, the relationship data as well in the same query by just configuring the relationship in those two tables, right? So now we can do the same thing for the users table as well, where I have users fetching addresses and so on. The next thing would be subscriptions, which is pretty hard to build on their own. So, for example, I'm running a subscription query over here, which will give me back the ID and name. I'm running this subscription query actively. So let me open up a new tab and then insert another data. And then we'll see how things change over here. This is pretty useful for real-time apps where you will, like, let's say, a ride-sharing app, tracking a driver's coordinates over a location. And you basically, what you do is you run a subscription against a Postgres table, and then Hasura gives back data whenever there's a change in the data of the table, right? So that's a use case that be pretty useful. So I'm going to enter my name. I'm going to click on save. I can instantly see that my data is reflecting in the subscription query that's still running actively, right? So this is pretty useful for this is like a live query which keeps running on this particular table, and it's pretty much optimized to run up to like millions of subscriptions for your application, right? So that's a pretty cool feature to have, to be able to build real-time apps with GraphQL APIs, right? So even consuming subscription APIs on the front end is a lot easier than REST APIs with all these client tooling, right? GraphQL clients make it a lot easier to consume GraphQL subscriptions and access data pretty easily in comparison to REST API tooling, right? So that's the basic GraphQL query subscription and mutation demo that I have. Next up, just to wrap up the feature set that you can try out on Hasura, which I talked about earlier. Is remote schema is something that you can try out, where you write your own GraphQL server in whatever language or framework, and then add that as a GraphQL endpoint over here. And what Hasura does is it adds this schema to Hasura's overall GraphQL schema that your application has. And then you can now start establishing relationships between the types over here and your database types and so on. So that's another feature. So this typical use case is when you want to write your own custom code in GraphQL itself by extending types. You write your own GraphQL server and then add it as a remote schema. But let's say you have like a REST API, which you want to add as a GraphQL API. Then what you do is actually you define the GraphQL query or a mutation that you want to add as a custom type. The type definition is over here. You define that. And then you specify the handler, which is a REST API, like a post API, post endpoint, right? The post endpoint will be given over here. And then Hasura will ensure that when this particular mutation of a query is executed, it will proxy it to your REST API, and your REST API will get a post request body, which will be of the format of the query that you send, right? So that's an easy way to quickly map an existing REST API to reuse GraphQL types and then make it as a GraphQL API, because eventually what you can do is you can actually make this as a GraphQL query. So let's say I define this GraphQL query, I leave all other things. Let's say I have fetch author, which subs an ID of type integer with sample output, let's say sample output, which has access token. And I'm just leaving everything else default. Now what you can do is go to API and then do fetch author, which can give you access token. And you also give an argument called ID of type 1. Obviously, there's a network error because we've not configured the URL. But what typically happens is that you can now map this query to your REST API endpoint, which is a post endpoint, and you can do whatever processing that you want to do inside that REST API. So pretty friendly for beginners who want to try out GraphQL, but they don't know how to define a GraphQL server from scratch. So this is a use case where you can reuse existing REST APIs itself rather than rewriting entire code base, and then just define types on top of your GraphQL service, right? So that's the demo. And finally, I think just to wrap it up, I think I'll show the REST API demo. So you can create endpoints from. So let's say I have users ID and name, and I want this to be a REST API, right? So what I'll do is I'll do fetch users, and I'll do a REST API. Then you can view this as an endpoint. Let's say fetch users, and location would be API/REST/fetch user. The method could be just get, and I can click on create endpoint. And if I send a request to this endpoint, I should be able to now get the response, obviously with the right authorization headers. I think I don't have the admin secret configured. So, but if I send the right authorization header with the secret, I should be able to now get the response for this particular REST endpoint. Because underneath what's happening is it's sending a GraphQL request for this query. So, so there's a REST API, it's configured. Underneath, there's a GraphQL request that's being sent. And the use cases have been different for different people. Existing tooling being used by organizations, they've been wanting to use REST APIs, and then they just wanted to configure a GraphQL API to reuse a REST API. And that's how this use case came in. So that's the demo that I mostly wanted to show. On the resources side, if you're new to GraphQL, or if you're starting out, if you want to learn about GraphQL, or if you want to learn about things around how to integrate with front-end frameworks, we have this learn section where you have all these tutorials, all open source on GitHub, with sample applications to try out step by step. So you can go to hasura.io/learn to try it out. And obviously our docs to try out our Hasura Cloud product. So this would be full stack tutorials. You have GraphQL APIs for beginners. The front end series would be covering all the popular frameworks that you want. Next.js, React, Vue, TypeScript, and stuff, along with your mobile frameworks as well. And there's a Hasura tutorial for you to try out the Hasura product itself on cloud, right? So this is a good resource for you to check out. Yeah, that's mostly what I wanted to show on the demo as well. Happy to answer questions.
Thanks very much for that. That was really very interesting. I was just wondering about the mapping with the table relationships. Can it pick that up without you having to create it all within the UI from an existing database?
Yeah. So even in an existing database, if you have like foreign key constraints set up, you can actually track any relationship between those constraints automatically.
Right. So they just come up as untracked, and you just got to click track on them, each one of them.
Right. Because some people do not want every relationship node to be available on the GraphQL schema. So you pick and choose which ones you want to.
Okay.
And this doesn't necessarily need to be configured through UI. There's a CLI tool which lets you do it through a YAML file. So it's all programmatically driven also.
Okay.
So we have a migration system where you can manage database migrations separately and your metadata separately. All programmatically can be done through your code as well, right? So UI is just like a fancy quick layer to do things quickly, but otherwise you can replicate all of this through CLI as well.
Right. Okay. And the custom functions, that's like Postgres functions, is it?
Right.
Okay. Yeah. Cool.
Yeah. So in Postgres, you can contact views, functions, everything.
Right. So you can use views as virtual tables in Hasura, kind of thing.
Right. So it acts as the same like how tables are behaving. So views is the same. You can query, you can do subscriptions on views.
Great. Okay. Yeah. Excellent.
Yeah, Praveen, that's very interesting. I've seen a demo on Hasura in the past, and it's quite fascinating. I've even tried to do a demo on it for our company. I work at the same company that Paul does, and one of the questions that actually came to mind was, typically in a more code heavy application as opposed to a no code or low code, you're not going to necessarily have a GraphQL API that maps to your database schema one-to-one. You're going to denormalize things or manipulate that sort of thing. So what kind of patterns do you see Hasura users doing to replicate that? Or are they more interested in getting stuff out the door so quickly that they generally just have a one-to-one mapping?
Right. So I think the one-to-one mapping is not always true. There's obviously going to be schema customizations all across. I think even on the schema layer, on also within the table layer as well. Like the columns might not be the ones that you want to. The names of the columns, everything might be different from what you want to expose to the client. Right. So what Hasura lets you do is because you are able to customize with views. Postgres views is a good option to start with, where it's not a one-to-one mapping of your schema, but your view itself is like now a mapping to your application requirement, right? So that's one step that we have seen people adopt to, and also you have something called GraphQL aliases and computed fields and so on, where the schema that you see over here, let's say the users table over here, you can now have a different field name for this, a different query name for this altogether. So, so that's another small feature that we have. But apart from that, if you generally your data fetching logic, I think even though it's not a one-to-one mapping, there's a close relation to what you can do with views and functions. And also on top of that, if you still have customization, we recommend writing an action where you write a REST API, which actually internally contacts Hasura APIs, and then you define your types accordingly. And then your handler, your webhook handler will basically be your REST API handler, which internally contacts Hasura APIs, GraphQL APIs for data fetching and doing some custom business logic around maybe validation, data validations, and so on. So primarily for us, I think mutations are primarily driven through actions and remote schemas. Typically, mutations require validations and some asynchronous logic post the mutation. So that typically has other use cases. So people don't use the auto-generated mutations as much, but we've seen enough people using the auto-generated query layer for the read access of data with all the patterns around joining between multiple data sources and joining between even within the same database. Like, for example, the query that I showed you for users and address, this is a pretty typical address and user query. This is a pretty sample query that a lot of users use in an e-commerce setup. For example, you have like a products table, you have images coming in, and that more or less is kind of mapping to the database schema. And wherever there is a change required, obviously there's a schema customization that goes through from the clients. So that's what we've typically seen. Mutations agreed on that people use custom logic like actions and remote schemas for writing custom code because there's validation involved. Like, for example, if you're inserting a user, you want to validate the email is right, and so on, right? So you want to do some kind of custom code before the mutation happens. So people use actions for that. And the eventual mutation is still through Hasura because the API is still there for you to quickly insert into the database. But for querying, we have seen almost a one-to-one mapping for the database and data sources.
Yeah, interesting. Thank you. Yeah, that's very, very interesting. Cool.
And also, especially in the subscription use case where real-time, for example, real-time apps, right? We've seen people using location coordinates, which are stored in Postgres, and people are subscribing to location coordinate data in a table. So it's basically a one-to-one mapping of the table data with real-time data, right? So and all of this is possible because you have a very granular permission system that you can define. For example, for this particular users table, I have a role called user. I can allow what columns they are allowed to access, and it's a very granular permission system to say how many rows I can limit them to, what custom check that I can have to allow them access to. So because of this permission layer, people are very comfortable defining this layer and then allowing access to the database tables directly as a one-to-one mapping.
Yeah, makes sense. Yeah, I only just touched the surface. I briefly looked at permissions, but yeah, I can see that there's a lot of depth there. So yeah, that's interesting. Cool.
Yeah, it looks great. It looks like it's come a long way.
Thanks, that's great.